Imagine a world where machines learn like we do. They observe, they adapt, they improve. This is the promise of machine learning, a field that has revolutionized the way we interact with technology and the world around us. At its core, machine learning is about teaching computers to learn from data without explicit programming. Instead of giving a computer a rigid set of instructions, we feed it data and let it figure out the patterns and relationships on its own. This ability to learn from data is what makes machine learning so powerful and versatile. From recommending your next favorite song to detecting fraudulent transactions, machine learning algorithms are transforming our lives in countless ways. But this journey of innovation has been decades in the making, marked by periods of both remarkable progress and frustrating setbacks. Join us as we journey through the fascinating history of machine learning, from its humble beginnings to its current position as one of the most transformative technologies of our time. The seeds of machine learning were sown in the 1950s, a time when computers were just beginning to emerge from their infancy. It was a time of boundless optimism and a belief that machines could be taught to think like humans. One of the earliest pioneers in this field was Arthur Samuel, a computer scientist at IBM. In 1952, he created a program that could play checkers. The program, which he called the Samuel Checkers Playing Program, was revolutionary for its time. It could learn from its mistakes and improve its performance with each game it played. Another significant development during this era was the perceptron, invented by Frank Rosenblatt in 1957. The perceptron was an early attempt to create an artificial neural network, a computer system modeled after the human brain. It could learn to classify simple patterns, but its capabilities were limited. These early breakthroughs, while rudimentary by today's standards, laid the foundation for the machine learning revolution that was to come. They demonstrated that machines could indeed be taught to learn from data, opening up a world of possibilities. The 1980s witnessed a surge of interest in expert systems, a type of AI program designed to mimic the decision-making abilities of human experts in specific domains. These systems used a knowledge base of facts and rules to solve problems, diagnose diseases, or provide expert advice. One notable example was MySyn, an expert system developed at Stanford University in the 1970s. MySyn was designed to diagnose bacterial infections and recommend antibiotics. It proved to be remarkably accurate, often outperforming human doctors in its ability to identify infections. However, expert systems had their limitations. They were brittle, meaning they struggled to handle situations outside their narrow domain of expertise. They were also laborious to build, requiring experts to meticulously codify their knowledge into a set of rules. Despite these limitations, expert systems marked an important step forward in the evolution of machine learning. They demonstrated the potential of AI to solve real-world problems and paved the way for more sophisticated approaches to machine learning. While expert systems dominated the AI landscape in the 1980s, a quiet revolution was brewing in the world of neural networks. Researchers had made significant progress in understanding how to train these brain-inspired systems effectively. The breakthrough came with the rediscovery of the backpropagation algorithm in the mid-1980s. Backpropagation, short for backward propagation of errors, provided a way to train multi-layered neural networks, enabling them to learn more complex patterns. This development breathed new life into the field of neural networks. Researchers began experimenting with larger, more complex networks, and the results were impressive. Neural networks started to outperform traditional machine learning algorithms in tasks like speech recognition and image classification. However, despite their promise, neural networks still faced challenges. They required massive amounts of data and computing power to train, which limited their practicality. The world was not yet ready for the deep learning revolution. Support vector machines, a new millennium dawns. As the 20th century drew to a close, a new class of machine learning algorithms emerged, support vector machines, or SVMs. SVMs were particularly adept at solving classification problems, where the goal is to categorize data into different groups. Unlike neural networks, which could be seen as black boxes, SVMs offered greater interpretability. They worked by finding the optimal boundary that separates different classes of data, making it easier to understand how they made their decisions. SVMs quickly gained popularity in various fields, including bioinformatics, finance, and image recognition. They were particularly effective in tasks like handwriting recognition and gene expression analysis. The rise of SVMs marked a shift towards more robust and scalable machine learning algorithms. They demonstrated that it was possible to achieve high accuracy without sacrificing interpretability. The Deep Learning Revolution, 2010s and beyond. The early 21st century witnessed the resurgence of neural networks, fueled by the availability of massive datasets and unprecedented computing power. This marked the dawn of the Deep Learning Revolution, a period of rapid progress that continues to this day. Deep learning algorithms, characterized by their use of deep neural networks with multiple layers, have shattered previous benchmarks in image recognition, natural language processing, and other fields. One of the key factors driving the success of deep learning is its ability to automatically learn hierarchical representations of data. This means that instead of relying on humans to hand-engineer features, deep learning algorithms can learn these features directly from the data itself. This ability to learn complex features from raw data has enabled deep learning to excel in areas where traditional machine learning algorithms struggled. From self-driving cars to personalized medicine, deep learning is transforming our world in profound ways. Convolutional neural networks, seeing the world anew. One of the most remarkable achievements of deep learning has been the development of convolutional neural networks, or CNNs. CNNs are specifically designed to process visual information, such as images and videos. Inspired by the structure of the human visual cortex, CNNs use layers of artificial neurons to extract features from images. These features are then used to classify images, identify objects, or even generate new images. CNNs have revolutionized the field of computer vision, achieving human-level or even superhuman performance on tasks like image classification and object detection. They are now used in a wide range of applications, including facial recognition, medical imaging, and self-driving cars. The ability of CNNs to see and understand images has opened up a world of possibilities, enabling computers to interact with the visual world in ways that were previously unimaginable. Recurrent neural networks, the power of memory. While CNNs excel at processing spatial information, recurrent neural networks, or RNNs, are designed to handle sequential data, such as text, speech, and time series. RNNs have a unique ability to remember previous inputs in a sequence, allowing them to learn patterns and dependencies over time. This makes them well-suited for tasks like language translation, speech recognition, and music generation. One of the most popular types of RNNs is the long short-term memory, or LSTM network. LSTMs are designed to overcome the vanishing gradient problem, a challenge that can hinder the training of RNNs on long sequences. RNNs have enabled significant advances in natural language processing, allowing us to communicate with computers in more natural and intuitive ways. From chatbots to virtual assistants, RNNs are transforming the way we interact with language and information. The future of machine learning. A universe of possibilities. The journey of machine learning has been one of remarkable progress and relentless innovation. From its humble beginnings in the 1950s to the deep learning revolution of today, machine learning has come a long way. As we look to the future, the possibilities for machine learning seem almost limitless. Researchers are exploring new frontiers such as reinforcement learning, generative adversarial networks or GANs, and quantum machine learning. Reinforcement learning, inspired by how animals learn through trial and error, holds promise for developing intelligent agents that can interact with the world and learn from their experiences. GANs, on the other hand, are capable of generating realistic images, videos, and even text, blurring the lines between reality and artificiality. Quantum machine learning, still in its infancy, explores the potential of quantum computers to revolutionize machine learning algorithms, enabling us to solve problems that are currently intractable for classical computers. The future of machine learning is bright, filled with exciting possibilities. As we continue to explore the vast potential of this transformative technology, one thing is certain: the journey has just begun. If you learned something new, like the video, share your thoughts in comment section, and don't forget to subscribe the channel for more related videos.